September 17, 1942, over occupied Norway, just north of Oslo. At approximately 10,000 meters, a German radar station tracked an unidentified aircraft crossing the coast at high speed. Within minutes, Messerschmitt Bf 109 fighters from a nearby airfield were scrambled, their pilots expecting a routine interception. What they encountered instead would quietly redefine how the air war over Europe was fought. The aircraft was a de Havilland Mosquito of the Royal Air Force, operating on a photographic reconnaissance mission. It carried no defensive guns, no armor plating, and no fighter escort. Yet, as the German fighters climbed hard and closed the distance, the Mosquito did not turn away or descend. It simply accelerated. Within moments, the gap began to widen. The German pilots pushed their engines to emergency power, watching the British aircraft pull ahead and disappear into thin cloud, untouched and unreachable. This was not an isolated incident. By late 1942, similar reports were filtering through Luftwaffe intelligence channels across Western Europe. Radar operators could detect the intruder. Controllers could vector interceptors toward it. Pilots could sometimes see it clearly, silver and unarmed, flying straight and level. But they could not catch it. Again and again, the Mosquito escaped not through evasive maneuvers, but through raw speed at altitude. For German fighter pilots trained to believe that bombers were slow, vulnerable targets, this represented a fundamental contradiction. The Luftwaffe's entire interception doctrine rested on the assumption that fighters, given sufficient warning, could always overhaul an enemy aircraft. The Mosquito shattered that assumption. It behaved less like a bomber and more like a high-altitude courier, optimized for one purpose only: arriving, completing its mission, and leaving before a response could succeed. What made this especially troubling for German planners was the Mosquito's apparent simplicity. Constructed largely of wood, powered by two Rolls-Royce Merlin engines, and lacking the heavy defensive armament carried by aircraft like the Lancaster or Halifax, it appeared, on paper, to be inferior. German intelligence initially dismissed it as a niche design, unsuitable for sustained operations over defended territory. Operational experience quickly proved otherwise. By the end of 1942, Luftwaffe pilots had begun referring to the Mosquito in frustrated terms, not as a threat they could counter, but as one they could only observe. Interception attempts were logged. Engine limits were tested. Fuel was burned. And still, the same result repeated itself. The aircraft they could see was the aircraft they could never catch. The growing number of failed interceptions forced the Luftwaffe to confront an uncomfortable reality. Reports from fighter units across France, the Low Countries, and Scandinavia were consistent enough to rule out coincidence. Pilots flying the Bf-109G and the newer Focke-Wulf Fw 190A models reported brief visual contact followed by immediate separation, even when attacking from a favorable position. In several cases, German fighters began their pursuit from higher altitude, only to watch the Mosquito maintain or increase the distance once both aircraft leveled off. The technical implications were alarming. At operational altitudes above 8,000 meters, the Mosquito's twin Merlin engines retained power exceptionally well. Its clean aerodynamic design, combined with a relatively light airframe, allowed it to cruise at speeds exceeding 400 miles per hour, faster than many German fighters could sustain without overheating or exhausting emergency boost limits. The Mosquito did not need to fight. It only needed to keep flying. German air defense doctrine had been shaped by earlier phases of the war, when bomber formations were large, slow, and predictable. Interceptions were calculated around climb rates, interception arcs, and the expectation that fighters would have time to maneuver into firing positions. The Mosquito disrupted every part of that equation. It flew alone or in small numbers, approached targets at high altitude, and crossed defended zones in minutes rather than hours. Attempts were made to adapt. Radar stations were ordered to detect Mosquito flights earlier, but early warning alone proved insufficient. By the time fighters reached interception altitude, the aircraft was often already outbound. Some units attempted head-on interception profiles, hoping to exploit the brief closing window. Even these efforts produced limited success, as the Mosquito's speed reduced engagement time to seconds. The psychological impact on German pilots should not be underestimated. Fighter training emphasized control, dominance, and the ability to dictate combat. Against the Mosquito, those principles failed. Pilots were reduced to observers. Aware of an intruder they could neither deter nor destroy. The aircraft became a symbol of technological and doctrinal mismatch, not through overwhelming firepower, but through efficiency. By early 1943, Luftwaffe Command acknowledged the problem in internal assessments. The Mosquito was no longer treated as a curiosity or an exception. It was recognized as a systemic threat capable of undermining air defense credibility across occupied Europe. Yet understanding the problem did not immediately provide a solution, and the reasons why the Mosquito performed so well were rooted not in any single innovation, but in a series of deliberate design choices made years earlier. Those design choices began well before the Mosquito ever crossed into German airspace. In the late 1930s, British aircraft designers faced a dilemma shaped by limited industrial capacity and hard lessons from the First World War. Geoffrey de Havilland argued that speed itself could replace defensive armament. If an aircraft could fly fast enough and high enough, it would not need gun turrets, heavy armor, or multiple crew positions. Every kilogram saved could be converted into speed, range, or altitude. This philosophy ran counter to prevailing bomber doctrine on both sides of the channel. German designs emphasized survivability through armament, assuming interception was inevitable. The Mosquito was conceived on the opposite assumption. Interception could be avoided altogether. By eliminating gun turrets, armor plating, and unnecessary structural reinforcement, the aircraft achieved an unusually low weight for its size. Its wooden construction, often misunderstood as a wartime compromise, actually contributed to a smooth aerodynamic finish and allowed rapid decentralized production. Power was the second critical factor. The Mosquito was equipped with Rolls-Royce Merlin engines optimized for high-altitude performance. Two-stage superchargers allowed the engines to maintain power where thinner air reduced efficiency for many German fighters. At altitude, where interception was supposed to favor the defender, the Mosquito retained speed and climb performance long enough to cross heavily defended regions without lingering. Equally important was mission discipline. Mosquito crews were trained to avoid unnecessary maneuvers. They flew precise routes, maintained optimal altitude, and resisted the instinct to react defensively. This calm, methodical approach denied interceptors the chaos they relied on to close distance. German pilots often reported frustration at seeing the aircraft continue straight and level, seemingly indifferent to pursuit. By mid-1943, the Mosquito was performing a wide range of roles over occupied Europe: photographic reconnaissance, precision bombing, pathfinding, and intruder missions against airfields. Each role exploited the same core advantage. Whether dropping a small bomb load on a specific target or photographing industrial facilities deep inside Germany, the aircraft arrived and departed faster than defensive systems could respond. For the Luftwaffe, this represented more than a technical challenge. It was a strategic embarrassment. Radar detection without interception eroded confidence in air defense networks. Civil authorities questioned why warning systems produced no results. Fighter units expended fuel and engine life with no victories to show. The Mosquito's success forced German planners to confront a painful truth. Their assumptions about air combat no longer held universally true. That realization triggered a series of increasingly desperate countermeasures. German engineers and tacticians searched for a technical solution that could restore the balance. If existing fighters could not catch the Mosquito under normal conditions, perhaps specialized units or modified aircraft could. High-altitude interception squadrons were tasked specifically with countering fast intruders, and engine upgrades were rushed into service to squeeze out marginal gains in performance. One such effort focused on extracting maximum speed from the Bf 109 and Fw 190 platforms by reducing weight and increasing boost pressures. Emergency power settings were authorized more frequently, even at the cost of engine longevity. In practice, these measures produced only brief speed advantages, often measured in seconds rather than minutes. Pilots reported that while they could sometimes close slightly during a dive or initial approach, sustained pursuit at altitude remained impossible. Night operations offered no relief. The Mosquito proved just as elusive after dark. German night fighters, burdened with radar equipment and heavier airframes, were even less capable of matching its speed. In some cases, Mosquitoes were used deliberately to provoke German responses, drawing fighters into the air and then vanishing, wasting fuel and reducing readiness for other threats. The Luftwaffe also explored the use of heavier, faster interceptors, including experimental aircraft and rocket-assisted concepts. While some of these designs showed promise on paper, they arrived too late or in numbers too small to influence the outcome. By the time prototypes reached operational testing, Allied air superiority and resource constraints limited their deployment. Meanwhile, the Mosquito continued to expand its operational impact. Precision raids demonstrated its ability to strike symbolic and practical targets with minimal warning. One of the most notorious examples occurred in January 1943, when Mosquitoes conducted a low-level daylight attack on Berlin, timed to coincide with a speech by senior German leadership. Though militarily limited, the raid had disproportionate psychological effect, reinforcing the perception that German air defenses could be bypassed at will. For German pilots, the lesson was clear and deeply frustrating. The Mosquito was not defeating them in combat. It was denying combat altogether. Each failed interception reinforced the aircraft's reputation as untouchable. Over time, the nickname took hold within Luftwaffe circles, reflecting resignation rather than fear. It was the plane they could see, track, and identify, yet never reliably engage. By 1944, the strategic consequences of that failure were fully apparent. The Mosquito was no longer an occasional nuisance but an integral part of Allied air operations. It guided bomber streams, photographed troop movements before major offensives, and struck high-value targets with a precision that larger formations could not match. Each mission reinforced the same uncomfortable truth for German air defenses. Detection did not equal control. Statistical records from the period underline the imbalance. Despite flying thousands of sorties over heavily defended territory, Mosquito losses to enemy fighters remained remarkably low relative to exposure. Most losses resulted from anti-aircraft fire or operational accidents rather than interception. For German fighter units already strained by fuel shortages, pilot losses, and increasing Allied pressure, repeated failed chases represented a costly misuse of limited resources. The aircraft's success also exposed deeper structural problems within the Luftwaffe. Interceptor performance alone could not compensate for systemic issues. Inadequate high-altitude radar coordination, limited endurance at maximum power, and aircraft designs optimized for a different phase of the war. The Mosquito did not exploit a single weakness. It exploited all of them simultaneously. British planners understood this advantage and continued to refine Mosquito operations accordingly. Routes were chosen to minimize exposure time. Altitudes were adjusted to sit just beyond optimal interception bands. Missions were scheduled to coincide with other Allied activity, further saturating German response capacity. The Mosquito became a tool not only of reconnaissance and attack, but of air defense disruption. For German pilots, this created a sense of inevitability. Training manuals and after-action reports increasingly acknowledged the difficulty, if not impossibility, of successful interception under most conditions. The aircraft's reputation spread beyond the front lines into civilian awareness, as air raid warnings triggered responses that ended without visible engagement. The Mosquito's presence was felt even when it caused no physical damage. Yet the story of the Mosquito was not simply one of speed or engineering brilliance. It was a demonstration of how doctrine, design, and mission discipline could align to create an effect greater than the sum of its parts. Where German planners sought incremental improvements, British designers had questioned the premise itself. Instead of asking how to survive interception, they asked how to make interception irrelevant. As the war entered its final phase, the Luftwaffe faced threats it could neither prioritize nor counter effectively. Amid massed bomber formations, advancing ground forces, and collapsing supply lines, the Mosquito continued to operate with relative freedom. It remained, to the end, the aircraft that German pilots could track, pursue, and curse, but almost never catch. By the spring of 1945, the contrast between expectation and reality in the air war could not have been clearer. German air defense systems, once among the most sophisticated in the world, had been rendered increasingly ineffective by aircraft that refused to conform to traditional categories. The Mosquito stood as the clearest example of this shift. It was not the most heavily armed, nor the most numerous, but it was among the most strategically disruptive. From a purely technical standpoint, the reasons were straightforward. A light airframe, efficient aerodynamics, and engines optimized for high-altitude performance produced speed where it mattered most. But the deeper lesson lay in how those characteristics were employed. The Mosquito was never used carelessly. Its crews relied on planning, discipline, and timing rather than reaction. Every mission was designed around minimizing exposure and denying the enemy opportunity, not meeting them head-on. For German pilots, this created a uniquely demoralizing situation. Air combat had long been defined by engagement, maneuver, and decisive outcomes. Against the Mosquito, none of those elements applied. Pilots could do everything correctly by the standards they had been taught and still fail. They could detect, scramble, climb, and pursue, only to watch the aircraft pull away, indifferent to their presence. The frustration was not born of defeat in battle, but of irrelevance. In retrospect, the Mosquito's success highlights a broader truth about technological competition in wartime. Victory does not always belong to the side that adds more power, more weapons, or more complexity. Sometimes it belongs to those willing to remove them. By stripping away assumptions and designing an aircraft around a single governing principle, British engineers produced a machine that reshaped how air defense was challenged across an entire continent. The Mosquito did not end the war on its own, nor was it invulnerable. But it forced the Luftwaffe to confront limits they could not easily overcome. It exposed doctrinal rigidity, consumed scarce resources, and eroded confidence in systems meant to guarantee control of the skies. In doing so, it earned its reputation among German pilots not as an enemy they feared in combat, but as one they could never quite reach. If you found this breakdown valuable and want more deeply researched World War II aviation history, consider liking the video, subscribing to the channel, and turning on notifications. It helps support the work and ensures you do not miss future documentaries exploring how technology, doctrine, and decision-making shaped the outcome of the war.